Okay, welcome back. Now that you've had a quick overview of some database basics, we'll take a closer look at MySQL Workbench, which you should have successfully installed along with MySQL. If for some reason you don't have this tool installed and don't have access to a similar tool, then please go back and find the right installation video for your operating system and get that installed. There are multiple ways to communicate with a database, and you don't need this tool. You can use the command line, usually through a special shell provided by the database vendor. You can use software applications, and that's our objective, to build a Java application that will interact with our database. But using a special integrated development environment built for databases does make life easier, especially when trying to debug issues. MySQL Workbench is designed for the MySQL database system. This means that it's a visual tool for database design and administration and SQL development. Let's take a quick tour. If you haven't already, the first thing I want you to do is open MySQL Workbench so you can see this welcome page. Remember to start the service if you didn't set it to start automatically. You should have two connections on this screen if you followed the steps I showed in the install videos. You wanted to use the development connection, so pick that. When you log in with this connection, your left pane will most likely be displaying schemas. Notice the tabs at the bottom or the top of the left pane which toggle between the administration pane and the schemas. In the install video, I already showed you how to use a couple of the administration tasks. We looked at the server status and made changes to the dev user account, assigning the DBA role to this user. For most of your work though, you'll be working with schemas. You remember a schema in MySQL is another name for a database. You may see some system databases, system for example, because dev user has the DBA role and therefore has access to elevated privileges and critical schemas. You want to ignore these, they're for use by the system and you can cause serious problems if you mess about with them without first understanding them. My installation of MySQL is showing these extra databases because this is the same machine that I previously recorded my SQL for Beginners course. Your machine won't show these extra databases. In a minute, we'll be creating our own schema or database by importing a file that will build one for us. First, let's step back and see what this IDE provides. As you can see, there are a lot of features in MySQL Workbench. In the main window, a tab is open that says Query 1. This is where you type SQL commands and it works like a text editor. This pane has its own ribbon of buttons along the top here with some functions we'll be using. We'll have a look at a couple of these in a moment. What I want you to do next is select the Administration tab of the left panel. Before we continue, go to Resources folder of this video and download the music_database.sql. This file was exported using MySQL and contains all the SQL code needed to create a music schema and several tables as well as a view. If you want to examine some data definition language or DDL, this script contains a series of it that will get executed as part of the import process. In other words, the file will get loaded and these SQL queries executed in the order they're defined in this file. Let's import this. Under the Administration tab, you'll see three categories: Management, Instance, and Performance. Under Management, the last option is Data Import Restore. Select that. If you have the bottom panel or right panel open, you want to close these so you can see the form in its entirety. You do this by targeting the buttons in the right corner of this IDE. Optionally, you could turn off the left pane as well. I'll do this so I have more screen space. By default, the Import from Dump Project folder is selected, but we want to select Import from Self-Contained File, the next radio button shown there. And you want to use the ellipse button to find and select the music_database.sql file you downloaded from the Resources folder. You have to know what's in your file, and this file includes the creation of the schema, so we don't have to specify a default target schema. In fact, we don't have to do anything else on the screen except click the Start Import button in the lower right-hand corner. Next, you'll see the output of the log shown in a second tab. the final line should say music_database.sql has finished. Close this tab, and if you did close the left pane, reopen it now. Select the Schemas tab in the left pane. It doesn't look like anything was added, and that's because we need to refresh the UI. That's the little icon to the right of the text, Schemas. Clicking that should now display music as one of the schemas. Open the music folder. Here you can see data objects shown. These folders are shown whether these objects exist or not, allowing you to create new ones. Open the Tables node next. Now you can see this database has 3 tables, albums, artists, and songs. Let me show you what's called an entity relationship diagram on a slide. An entity relationship diagram is similar to a class diagram. An entity is a table in this case, so all 3 tables are shown here. The column marked as a primary key is identified by the key icon and PK letters. The primary key is separated from the other columns, as you can see. The additional columns are listed. Relationships are shown with connector lines which describe how 2 tables or entities relate to one another. Both of the relationships shown on this diagram are one-to-many or many-to-one, depending on how you look at it. If I read this document, I have songs, and many songs may be on a single album or record in the albums table. The album ID is included in the songs table as what's called a foreign key column. This column's purpose in the songs table is to specify the related record, which makes joining the tables much easier. Albums may have many songs, but in this model, an album has only one artist, so the artist ID is a foreign key column on the albums table. An artist, however, might be on many albums, so it has a one-to-many relationship with albums. Let's see what this looks like in the MySQL workbench. We're going to use this database for many of the upcoming lectures, so it's kind of important that you understand it. The easiest way to do this is click on the music schema in the left pane. We use the schema inspector to learn more about the music database. You can right-click on the music schema and select Schema Inspector. Alternately, you can select the third icon on the toolbar menu, third from the left, that has an eye on it. This opens a new tab with a tab panel and shows a few details about this schema, such as table count and an estimated database size. You might wonder why this has a table count of 4 and we've only seen 3 tables. This count includes views, and I'll talk more about the view in a minute. The tabs are labelled Tables, Columns, Indexes, Triggers, Views, Stored Procedures, Functions, Grants and Events. Let's click on Tables first. The main thing of interest here is the column labelled Rows, which tells us how many records are in each table. Now let's click Columns. This shows the columns for all the tables as well as the view, which is named Album View. You can see the column name and types and whether nulls are supported in each, for example. In all cases, except the ID fields, the values can be null, meaning not every column is required to have data. Let's look at the Indexes tab next. In this case, we can see each table has a primary index, which is unique, and the column used is shown here. In addition, there's an index for each foreign key, and this index isn't unique. Let's now take a look at some of the data. I'll open the Tables node and click on Albums. Notice the 3 icons that appear when this table is selected. The icon we want is the last, the spreadsheet-like one. Clicking on that opens another tab with 2 panels. The top bottom shows the SQL statement that was executed. The bottom panel lists the data in the table. If this is your first look at an SQL statement, this is a very common statement. The select command will get the data. A list of columns would follow this command, but if you enter an asterisk or star, you specify you want the data in every column. The from clause will specify what table or view the data should come from, so here it's coming from the albums table. Notice that the albums table includes the schema or database name. Okay, so that's a super quick look at this workbench and the music database. I want to encourage you to use this database to get familiar with Workbench. You can always delete the music database and re-import it, so try to spend some time here if you have it. Before I end this video, I want to look at the view. A view is sort of a virtual table. Let's open the Views node and select Album View, and again select that last icon. This will do the same thing as we saw with albums, so the query will be on top and the data on the bottom panel. Here, the data doesn't have any IDs and has data from all three tables. This is a full look view of all the pertinent data in all the tables. Let's look at data for just a single album. To do this, I need to add a where clause to my select statement. A where clause takes a column name, so in this case I want to search by an album name, and I want that album name to be equal to Argus. Strings are always enclosed in single quotes. To execute this query, I can choose the lightning bolt icon. There's two lightning bolts and either would execute this statement. The first is a bit more flexible because it lets you select a portion of a complex statement and execute only that selected portion. If you have no selection, you can execute either. Now, the data in the bottom panel, the result grid, is showing the songs for only the Argus album, which is an album by the artist Wishbone Ash. Remember, album name is stored in the album table, artist name is stored in the artist's table, the song title is in the songs table. A view is a SQL select statement that's saved and given a name. The data is not saved in the view, only the SQL statement is saved that will return that data. We can use this view's name to easily query data. You can think of the view as a type of encapsulation. It's hiding information about the table structures and relationships and displaying only the columns deemed necessary for the client. In fact, the client might never have to know that this data is stored in three tables. When a table structure changes, the view may not have to change, so any software reliant on these structures can remain unaffected. I'll click on Album View again in the left pane, but this time I'll select the second icon, the tool icon. This will display the stored query in a tab. This statement consists of DDL and DML statements. It's creating a database object, a view, named Album View with database definition language, the command create. And it's storing a DML select statement. This select statement is executed when we select data from the view. Notice that the from clause is selecting data from all three of our tables using a series of joins. I'm not going to get into the details of this statement. The main thing is that this view has all the information we want to query about the albums, artists and songs, and our Java code doesn't have to understand too many details of the schema itself. We'll be using this view in a lot of our Java code, which means we don't have to write code with these joins in our Java code. Okay, so I'll end this video here. In the next video, I'll show you how to connect to this database from a Java application, so let's go.